So good afternoon, everybody. Yeah, so today we'll be looking into networking for hackers. In our first session, I remember we understood the CIA triad, and in our second session we did a little practical. We played it a little too. So today we're going deeper. So we want to understand how communication actually works, how communication happens on the internet. So So if you want to understand hacking or defense, so now if you were with us in the first workshop, you should understand the hacking and defensive parts of cybersecurity, the red hat and the blue team. So if you want to understand hacking or defense, you must first understand how systems talk to each other, how networking works. So this sounds like the foundation. So why networking matters in cybersecurity? Okay, let me be blunt. You can be the best exploits developer in the world. You can be the best hacker. You can be whatever. But if you don't understand networking, you're just how will I put it? You're just like a sniper. Like a sniper now operating in total darkness. So you might have the bullet, you have your weapon, you have your gun, but you have no idea where your target is. So is for a sniper, you need to be seeing your target. You need to know what exactly you're trying to hit. So this is how I'll relate it to networking. So in cybersecurity, the network is the ground truth. So um why cybersecurity, why networking matters in cybersecurity. So um we say logs can be deleted, malware can be hidden, but you see traffic like the networking, it can't lie. So everything you're doing really matters, like the networking. So everything a hacker does, like from the beginning till from the initial stage to the final stage where he exploits things, he must leave a footprint on the wire. So if you understand networking, you're going to understand visibility. That is, you're seeing what device are actually live. So not just what you think is live, not what you think, okay, this port is open or um this server is open. So you're understanding the path, knowing how to bypass a firewall, knowing how to find a misconfigured route. So this is what hackers are always looking for. Persistence, you're understanding how to keep a back door open without triggering an IDS. An IDS is intrusion detection system. So you want to gain access to a system without you identifying the company. Let's say, for instance, that some you see some hacking that just happened. They didn't just happen in a moment. You see some of them, some malware have been stored for months, for days before they have been exploiting things before the people won't know. So this is what they want to do. This is because of the networking. So they understand the way the computers, the system communicates to each other. So um, what most hacker does now isn't just really magic. When people think about hacking, it'll be like and it's really a very big thing. Like it's just like magic, but actually it's just simply misusing the rules of network, just tweaking some of the rules there. So like for instance, a DDoS now isn't just a glitch like in a server. It's just an overwhelming protocol ability to count. So a lot of um servers are just attacking one person. It just gets jammed. It's just as you bringing somebody and putting much load. The person can maybe, let's say, carry a kg of let's say 50 or 100 kg, and you just keep on adding, so up to 1,000. You see that person definitely doesn't give up. So every cyber security every cyber attack uses a network. The data moves in packets. So going forward further, we'll understand what a packet is, and also communication follows rules, which is protocol. So understanding traffic is equal to understanding attack. So someone saying something. Okay. All right. So how do the internet actually works? So we really, how does this internet of a thing really works? How does it work? So every time we open our website now, our computer is actually communicating. Every time we log into the internet, our computer is communicating with one computer somewhere in this world. So don't just think it's just like something that is just happening at random. No. So and things that makes this communication possible are things like the IP address, the packets, the protocols. So let's think. Let's use an analogy now. So think of the internet as a postal system. So like the postal system now does everything that pertains to it now. So we have the IP address as our home address. So we have the packet now as the envelope that you're trying to deliver. So the protocol now should be the delivering rules. So our IP address. So we want to use this. Just picture this now. When I say IP address, you're seeing the home address. Your home address. When we say the packet, is like the envelope. So when we say the protocol, it's like the delivering rules. So and now most of the time, I myself was I've been told about like the internet, like you should see it as a cloud, like it's a cloud. The internet is just like a cloud. So sometimes I wonder how those things happen in the cloud. Like it makes no sense though. But that's totally not true. It's just like a marketing stuff about the internet. So for us now, internet is more than just a cloud. It's massive. It's an interconnected web of physical cables, routers, and protocols. So if you want to exploit a system, you have to stop seeing websites and start seeing the journey a packet takes to get to there. So if you want to exploit a system, you have to stop seeing the website like just the website. So you have to see how the we say the packet should be the envelope. Know how the envelope move, like how do they take it? How from what route does it follow? So for example now it starts with just a name like let's use google.com now for example. um google.com now. So if you see now what we are seeing is just google.com, but actually the computer speaks IP address. I'm not seeing those in words. So it's like our computer does see the speaks address is not actually our normal English. This is just like plain language for us to understand. So once we hit our search button or hit an enter button now in the system just for it to was searching for something now. So the computer now reads those things, those information, not the way we see it. So those are what we actually want to understand. What really happens there. So our bullet points now we have that devices communicate using IP address. So the data is broken into packets, so it doesn't just go once. So um our IP address now. So let's say once we have our IP address now, our data, let's say we want to send something. For instance, um, I get a picture and I said, I want to send to Chisom. I want to send something to you. So the data now is being chopped into tiny small pieces. So those pieces now are called packets. It doesn't just go once, like you see it like a very big stuff just coming in. It's being chopped into tiny pieces called packets. So and these packets don't just fly to you. They don't just okay, I from here send it. So let's say um wherever maybe I'm in Abuja now, you're in Lagos or wherever in this country and I press send, it doesn't just fly from here and land on your phone in Lagos there. So first of all, the computer breaks it into pieces, tiny little pieces, so which is the packet. So remember now we equate our packet to an envelope. So now, and we have our IP address as the home address. So it gets your IP address, that's the destination it's going to. Then it's how do I explain this now? So it gets your IP address. So then it goes through a gateway. First of all, the gateway protocol, BGP. So the broader gateway protocol, it goes through it, and just like a digital bucket now, bucket brigade, whereby it's like a brigade that there are people standing. You have to pass it from one hand to another to it get to the end point. So this passing through now is what the hackers are trying to intercept. So when I'm sending this, because it doesn't just fly, let's say assuming it's just like from here, it disappears from here and appears in your phone, in your phone or at your location now. So there's no way anybody can even get it. But if that's the case, there wouldn't be any reason to be hacking. But since it gets through get through protocols, there are some things it has to pass through. This is where hackers, this is what they try to intercept. So they have like, okay, the IP address, the route is going to, let's use the postal analogy now. If for let's say for instance you want to send something to someone, you want to send an envelope. Now a thief would know, first of all, know that, okay, there's an envelope coming to this address. What are the routes that this person will take? The delivery guy, what are the routes that he's going to take? So can we sniff this too? Can we check and know it? Or can we actually pretend to be the house, like clone it and be a wrong house? So instead of going to the right house, you send it to the wrong house address. So, and this is where we can, okay, DNS now. So that is, they can poison the location, the address, to sending it to the wrong house. Then the route to where it's going to, they can use sniffing to the course of this section we'll see through Wireshark and how to even know what is Wireshark. So with Wireshark now, they can know what is actually inside. So you're sending a packet, I'm sending a packet to Chisom, so they can sniff, okay, what actually is he sending? What is that thing that is inside there? So if it is not secured, it's going to be exposed. So, and the destination, which is yours, they can now clone the destination where this thing is going to, and then they would impersonate it. So the internet as a whole is being built on a trust. The internet. So our job is to understand exactly where that trust is misplaced. So, because if a trust is being misplaced at one point, that is where, I'm just trying to make this as simple as possible. This is where hackers can now come in and say, okay, there's a guy that is supposed to pass it to, okay, A is supposed to pass to B, then B to C, C to D. But at a point, there's something that happened along the way. B and C had maybe a little issue. Now it's being skipped to D. So you don't actually know if C actually got the right packet or something happened that way along the way. So this is why cybersecurity. If you remember in our first workshop, we were talking about the CIA tribe of cybersecurity. So this is where confidentiality can be broken, integrity or others. So now what happens if this packet I'm sending to Chisom gets lost? What really happens if it gets lost? So in the world of networking now, a lost packet isn't just like a. Can you guys hear me?
Yeah, for me.
Okay. So if I'm sending, let's say I'm sending a packet to you now, and it gets lost. So it's a bit like still using the mail delivering box now, like a mail being handed to a delivery guy and the thing falls off the track. So what happened next entirely depends on the protocol that are being used. So, because if the agents that were being used to send that delivery, the agents I'm using to send to you, let's say I want to ship a MacBook or a laptop to you now, and along the way it gets lost. So it totally ties down to the agents that I use to set it. They can handle it in two ways. Either there's going to be a panic and they fix it. There's going to be a panic. So they'll be like, oh, we lost a customer's packet. So the panic does come. What do we do? What do we do? And they will find a way. Either they refund or compensate or whatever and fix it. Or they'll just forget about it and just keep going. At the end, they can just like that. We actually delivered this. It looks like your the receiver didn't get it or something. It's not from us. So that's why I say it does depends on it. So bringing this now to the networking, in the world of networking, so a packet now totally does depend on the protocol that is being used. So when we're sending something, um, some sequence slides, we're going to understand it. So if you see here now, we say that the protocol controls the delivery. So this is what I'm just trying to explain. The protocol is like the agent. It controls the delivery. So the delivery rules, remember we gave the analogy that the protocol has the delivery rules. The packet is like the envelope we're sending, and the IP address is like the home address. So if something happens to the packet, it now ties down to which protocol are we using to send it. So okay, first, what's an IP address? An IP address, for short, is Internet Protocol Address. So it's a unique numeric label assigned to a device or a network. This is the short of IP address. IP address is stand for an Internet Protocol Address. So let's think of the internet in terms of names like google.com, or okay, we're using Discord on Discord. Let's say discord.com now. So now the hardware doesn't really care about those names, like I say in the beginning. These names is just for us. What's to every router you're seeing now, what they are actually saying is a unique number, a unique address. So it's not saying that you see that you're saying google.com. That's not what the computer is actually saying. It's not saying google.com. So an IP address now is the unique number assigned to every device on a network. So if you don't have an IP address, so let's say for instance now, google.com is like a school, and you just click on google.com and you enter inside the school. So now they'll have to say, okay, there's an entrance. Who entered the school? Who is it that entered? So they have to say, okay, is it a man? Is it a boy? Is it like there's an existence of somebody inside the school? So it's just like the IP address now gives its address. It gives you, it identifies you. So if you don't have an IP address, it's just like you don't exist in the rest of this world. So most of what we deal with today now is made of IPv4, that is in version 4. So it has 4 octets. So you can see the example now. So we have 192.168.11. So, and here's the secret now. So IP, those numbers now are just being in 32 bits binary. It's been in 1 and 0. So in computer now, this is for those that are understanding. Computer always systems as 1 and 0. So we have the public and the private IPs. So the public IP now is like your face on the global internet. Like when you come on the internet, is the whole world. This is what you enter. This is what you identify as. So you can see the number. Okay, Google now say Chisom has popped on in the internet. That is the IP, the public IP. So why the private IP now is like your internal identity behind the router. So like your real. So now online now, let's say for instance, online now here we're seeing you as Chisom, but behind the face Chisom, who is actually there? Do we know? You can see people using female names online. But this is just like an analogy, but in the networking now. So your IP, your public IP address now is what is for the global. Once anytime you go online, there's a unique address that you enter there with. So we say the IP address is just like the home address. So it tells the network where you are. It tells the network let's say it changes. If you move, it will change. So like let's say you were at Abuja in the morning and you're browsing something, the network will be identifying that okay, this person is actually at Abuja. Through the IP address, we know that okay, this person, the location of this person is in Abuja. Then in the evening, you change your location, you're now at Ibadan. So you see the IP is going to change. Now, let's see. the IP. Sorry. All right, I think I'm back. Can you guys hear me now? I think I have a glitch in my network.
Yeah, I can hear you.
Okay. So, the to keep it straight now, our computer gives us a name. Let's say, for instance, like the google.com has an IP that you say, okay, once you see 4142 or something like this, you see the name. Then the social, if an IP is your home address now, the computer has a MAC address, which is like the your fingerprint. So your home address changes when you move, but your fingerprint is the same. So if like I was saying, when you're in Lagos or Abuja Provincial in the evening, you change your location, which is your IP address. It changes from Lagos to Ibadan, but your MAC address is still the same. It's just still the same. So I think let's just we're supposed to go all theoretical today. But if you're with your PC now, let's just see check our IP address. So let's do a little practical. So permit me the head. Mario, permit me. So and are you guys still seeing my okay, it's back. So
Yeah.
on your PC now, if you're using who should we do? Okay, Chisom, are you with your PC there?
No, I'm not. I'm not.
Oh, okay. I would have said, but
I'm with mine, sir.
all right. So let's do a little practical now to see our IP. So on your PC now, are you using Windows or Mac, if I may ask?
Windows, sir. Windows.
Okay. Okay. So good. So now press the Windows key and type CMD and enter. So CMD, that is you're opening your command prompts and enter. So
Yes, sir.
are you here?
Yes, I'm in, sir.
Okay. All right. So now we want to run this command. Get Mac. So get G O and space then list. So
All right. Sorry, sir. I had a network break. Get Mark GET space Denmark.
wait, no.
Let me see.
Get Mac. Okay, I think let me type. Okay, let me share my screen. Let me see if I can share this too. Just a minute, guys. Okay. All right. You can see the screen, right?
Yes, I can see it, sir.
All right, so we want to see the IP address now. Get mark. Why? Okay. Why is it not even? Is it? Yeah. Yeah. Okay, let's just use this one now. So if you should see now, let me just bring down here. Right here now, you're seeing my IP before address 10.171.232.16186. So with this now, with the address now, this is what brings identify me on the internet. Like I was saying, this is what if I want to send an image to Chisholm, it will have to pieces it into small units. It doesn't just send it as a whole one. So it pieces them as small unit before it goes there. Then when the receiver gets receiving it, it brings it. It's just like saving them in batch 1, 2, 3, 4. So it loads them together. Then batch 1 comes 2, 3, 4, then present it to the receiver that this is what was being sent to you. So a packet is like the vehicle. So in context of this workshop, now let's just call it the unit of interception. So if you see how would I put it? Let me still use this analogy I'm still using. So I'm sending, let's say I want to get a car, and I take the photo of the car, very HD quality, and send it over. So it doesn't just come as the giant file, like I said. So it comes like thousands of tiny pieces. So series, remember the packet now is like envelope, like we said. So series of envelope are just being sent. So now, in the world of networking now, the packet is like the atom. Yeah. So remember in science, they say atom is the smallest unit. So the packet now is like the atom in networking. So every tiny, um, smallest functional unit of data that can travel across wire. So now the packet is more. It is more just than the message that's what I'm sending. It is like a structure. It is like a letter inside an envelope. Let me put it that way now. So it is like a letter inside an envelope, which is still inside a shipping box. So now, this is what people are trying to sniff the packets. So they want to really know what is inside it. So because in the packets now, you see that they want to see what actually am I sending to the receiver, what is being received. So inside the packet, we can get a lot of data. Everything you can just the data. The packet is the data itself. So now, we have like um okay. Now, why are hackers even really so obsessed with packets? Like, why? Because you see them, they don't want to eavesdrop, they want to sneak the packets, they want to really get it, they want to just hijack it, or even clone the destination and claim to be the address, the receiving address, so that they can get it. Because this is where the data is. This is what carries the main information. So this is it's like the digital gold shall we have. So people just want to intercept it to get it. So packet sniffing like is like the ultimate form of like eavesdropping now. So people just want to know what is inside. So we use the tools like Wireshark. Remember, we'll be along the line, I'll introduce us to Wireshark, and maybe in the next class, I think, we'd have to do practical there. So, now the packet can be um, encrypted or it can be unencrypted. So, if it's unencrypted now, if the packet is unencrypted, so meaning that if it gets lost along the way, anybody that takes it will see what, like it will see it in plain text, what is actually being sent to the receiver. So, and we say the packet now contains the source IP, the destination IP, and the payload. So it contains where it's going to. So I'm sending a file to Chisom. The packet has it. So it contains the data. So this is what the hackers are trying to just intercept and get. So if a packet gets lost on the way now, I think I've said this now. So I'm sending. I think there are some things you see that you send something and you see the message cannot be delivered. So what really happened? So is it that the message, the packet, once it gets lost, what happens if we send something and it gets lost? Is it that our data has just gone? Okay, for example, now I want to send to Mario the my bank details. I want to send him, guy, this is my login. This is what some hackers used to just get some people to say, oh, the doctor said that okay, I have some humans to believe this is my login, this is the password, this is the username, this is the bank. So some people still fall for that. I don't even know how. So now we have like the protocol, which is what, like I said, it now depends on the protocol. I think that should be, yeah. So let me just introduce us to the protocol now. The protocol is like a set of communication. So protocol is like it defines how data is being sent. So is a rule, the communication rule that okay, see, this is how we're going to communicate. This is how the stuff is going to work. So if something should happen, now it ties back to the protocol, and we have few protocols. For example, now we have the TCP, that's the transition control protocol, the UDP, the user datagram protocol, and the HTTPS, TTP, hypertext transfer protocol. So now, if we're using TCP to send data, TCP is mainly used for like browsing, emails, files. So TCP has a strict rule. There's no packet that is being left behind. So if I'm sending a packet and they discover that okay, this one is not there is a packet missing, they will find it. So like that message is going to be on the hang until that data is being sorted out. So TCP is known for detection, the transmission. So now the sender gets a time. This is why you see you're being timeouts. You're trying to type something and within a few seconds, maybe network delays, and you're just saying timeouts because there's an allocated time between seconds. They believe that okay, you should respond. I think this is okay. I would say, hey, I want to send message to you. Are you available? Where are you from? I'm sorry, what introduction? Yes, I'm available. I want to receive it. So if they are sending a data to you now and there's no feedback, so they'll be like, okay, you didn't receive this, and they'll like try to resend it again. So this is for TCP. So if the computer now is using TCP to send the data. Now going back to here now, if computer using TCP to send our packets, so should in case something happens along the way, there's going to be it's going to come back and try to see okay what really happened, where was this broken. Remember, like I say, okay, it's like a brigade bucket now where people are crossing. There's a line of people numbered 1 to 10, number 1 2 3 4 5 to 10, and we have A and B at the extreme of both ends. So A pass it to number one. So for number one to pass to number two until it gets to B. Now, if let's say A pass the packets to number one starts moving, then along the way there's a delay. So now with the protocol we're using TCP, it's going to go back. Like once A doesn't get a feedback from B that he has received it, it's going to be like, okay guys, bring it back, bring it back. Let's try it one more time. So this is how the packets does communicate. So it sends like a ping. Let's say for instance I go on google.com, what is my IP, and I press enter. Now I've sent a packet. If it doesn't, if now my system see that the network doesn't return in between some seconds, you see bringing back an error message that request is timed out. So now it's like Google didn't receive my request. I should try this. Me, that's why you see some people, once you see try timed out, you refresh, try again, try again. This is just like trying to send those stuff back and back. So the protocol is like a set of communication rules that define how it defines how data is being sent. It ensures that system understand each other. Like I said, it has to ensure from the receiver, are you available to receive this thing? Let's say it's like a middleman. I'm trying to send something across to Mario now. It will ask Mario, hey, Gospel is trying to send something across to you. Are you available to receive this? If it doesn't get feedback from Mario, it doesn't establish a connection. So there's no connection. So it has to establish a connection first with Mario. Then it will now send it down to him. So UDP is the one that doesn't really care if there's a connection or not. Like it just sends, whether the packet is being lost or not, it doesn't care. So its own is that you sent me, I've sent it, it's been delivered. Did you actually deliver it? I don't know, but I just know that I have delivered it. So we say the protocol is a set rules of communication. So protocol is like the bridge between the hardware and the communication. So the protocol is the language which is written on the letter. So it has to have there have to be an understanding between the two parties. So for us now, the protocol, like in cybersecurity now, let's say okay, the hackers now, the defenders now, the protocol is not just a rule, it's not just a set of rules. So it is a contract that we look for loopholes for. So this is where we are trying to look for loopholes. Is it being secured? What protocol is being used? So this is what actually the protocol is what hackers are actually looking for. So now I'm sending a packet to Chisom. They want to first of all know, these delivery guys, are they really secured? Can I intercept them and get away scot-free? So they are trying to look for loopholes. Okay, the guy is going to follow route 1. If I intercept him at route 1, would there be available means of interception? So these are what hackers are trying to gain. So without protocol, the internet is just going to be chaotic. Like it's just going to be chaotic. So protocol provides like a structure. So they define who speaks, how long they can talk, and how to say goodbye. So for instance, the TCP now, if okay, it's just like an instance for a call now. You're on a phone call with somebody. Being on a phone call with somebody, you have to confirm, okay, this person, you don't just call someone and start let's say you want to make a transaction, let's say ₦1,000,000, and you just dial the number of your friend and just start saying, hello, I'm going to transfer 1,000,000 to your account now. I want you to use this and go and get this. You haven't even heard from the end if it's actually your friend that picked the call. You don't even know if it's someone else, or like is the communication established or not. So TCP ensures that one, that okay, before you start talking, you have to say hello. You get a reply, hi. So you have confirmed there's a connection now. You have confirmed that yes, the receiving end is active, you're active. Then this is how the network begins to flow. So introduction to TCP. So TCP is connection oriented. That's what I just explained now. It has to ensure that there's a connection. There is a connection before it start doing anything. So reliable delivery, like I said too. Once you're sending something, it has to make sure that it has delivered. If along the way discover, okay, we forget the packet at the headquarters, it will go back and pick it up. So if you're downloading a software patch now, let's say you want to update something now, and you wouldn't want to download half and just leave. Um, let's say you're downloading one to something tagged 1 to 5. You're downloading 1 2 3 4 5. You can't just download 1 2 5 or 1 2 3 5 and skip 4. You have to download everything. So this, if one misses, it will just corrupt the whole file. So this is where TCP comes in now. So TCP, we see TCP as the perfectionist in the networking world. So it has to be perfect. TCP say, okay, for this thing to work, it has to be perfect. There is no error. If there is error, it will try to make sure that, okay, we have recovered that error. If a packet go missing, we have to go and say, okay, it will tell you, send it again. I think this packet didn't go through. Try to send this again. That's why you see timed out. You see that you're trying to get something from the internet, you're not getting it. You receive timed out. TCP is telling you, okay, actually this didn't go through. Can you send this stuff again? So now, like I said, we just imagine I call Mario now. I'll have to confirm first that he picks up and they are listening. I don't just talk. So they have to be, and TCP also um it also makes sure for ordering. It has like, let's say for instance, the analogy I give when I'm sending a picture to you now. I want to send a photo of the car I took picture of. You won't just send as a big file, it's sent in bits. So, and I said, like, it sent a package, like, let's say number one, it will number them, like, for instance, number 1 2 3 4 5. And you know how the network is now. You might see that you send one first, maybe you just send all of them in sequential order, but at the receiving end, 5 is coming, 4 is coming. So TCP now would, it has like a waiting room. When it receive 5 4 3, all this number, it receive every package. You say that, okay, the sender said, I'm sending you 10 packages, and the receiver at the end, it will be like, okay, 10 packages. You send one, it just keep them in waiting room until the whole package is complete 10. Then it starts arranging it in order how it's supposed to be. You have written this one number 1 2 3 4 5 6 till 10. So it arrange it that way, then deliver it. So you don't just, when you see missing information coming out, you don't see it scattered, or you see it being ordered. This is how TPC flows. So now, for hackers, TPC is like a double-edged sword now. So it has the good side and the bad side. So the good side is that because it's so structured, like it's a three-way handshake now. It's a three-way handshake in the sense that the first handshake is to confirm if you're active. So the second handshake is you sending me a reply that yes, I am actually active. Then the third handshake, now the communication now goes off. So now, to we can use this three-way handshake now to fingerprint a target. So you see now, when TCP is like the good side for hackers now, so you see that, okay, this thing is actually going somewhere. So now you're going to wait for the feedback from the receiving end now. Like I said, you first of all say hello. So the hackers now, it's just like they are listening. You sent hello. So where is this hello actually going to? Because TCP, it will go and knock at the receiver side and say, okay, are you active? There's a communication coming in. So now you reply, you now say hi. The hackers are now say, oh, this is where he sent it to. This is where the network, the information is coming back from. This is where the response is coming back from. Now, this is where the good side is now. So they can now look how to respond to those servers. So now the bad side is that because TPC requires so many acknowledgements, like the 3 ways, so it's much easier to defend it. So it's much easier. Or if there's an interception now, it's easier for them to just know that, okay, So why transferring money now? Now, for instance, now can you guys hear me? So
Yes, sir, we can
let's
hear
give
you.
an example
Yeah.
now. Why transferring money now? You see, let's say if we are trying to transfer money, like you want to transfer cash now to, let's say you're paying for a job, or no, let's say you're receiving money now. Your boss wants to transfer money to you now. Would you prefer speed or accuracy? Do you want, if your boss sends, let's say you want to be given $1,000 now, and they send it $1,000? Do you prefer that instantly you receive one, you receive an alert, or you prefer that you receive an alert, though it might not be very instant but it's still fast, but it ensures that okay, you're receiving $1,000? Because in that speed now, you can, your boss can mistakenly type two zeros instead of 1 0 and send it. Okay, you say, hey, I sent you $1,000, and you check, you're seeing $100. You'll be like, what's happening? Please just calm down, calm down. This is where money, this is money involved. Calm down and do this in the right way. So this is how this is where TCP comes in. It ensures accuracy over speed. Why UDP in the other end is what it doesn't care about accuracy. It just wants the speed. Like okay, very fast. Like for the streaming of a football match now, you don't really care about the um accuracy of it. You just want to be live. You just want to be seeing this live. That okay, they pass the ball, they have dribbled the guy. You want to be seeing it live. You don't really want to see, because if in terms of accuracy now, once you see that okay, the protocol sees that let's say for instance, if it's TPC now you're using to stream, imagine it sends a packet, it's missing, it has to go back. That's when you see that it has to go back and start looking for the missing packet, because it ensures accuracy. It doesn't really cover around speed. So but for UDP now, it's like just get it done, just get it done. So you're watching you're streaming a match, you're streaming a game now. It ensures fast that okay, this thing is very fast, it is live. So the TPC has like the rules that um in, how would I put it now, the all or nothing, rule. Let me just put it like that everything comes intact or nothing comes in at all. So everything, I'm sending $1,000 to you, so it has to ensure that okay, it's either that 1,000 I'm sending to you comes in as 1,000, or it banks it back and tell you that oh, that there's an error in this place. So this is what TBC does. So it has the integrity, so which is like yes, they didn't make the mistake, so it has to check. You're sending 1,000, what's the package being delivered? Is it 1,000? Is it 100? So it says that okay, it's 1,000. Fine, let's just send this. So now TCP is if we want accuracy, it is where TPC comes in, TCP comes in. So we say that it is connection oriented, reliable delivery. So error checking. So packet sequencing, whereby it orders, it gives it the order, it sends it in the right order. There is used for critical data. Yeah, for example now, you're transferring files, you're transferring money, the banking system. So that's the word of TCP. So okay, the characteristics of TCP. This is what I was trying to explain. So the three ways which TCP try to go synchronize. So it send first to see if actually the receiving end, like if we see now, it ensures connection oriented. So it ensures that there's a connection first. So which is the first one? The SYN. So it sends that okay, um, is this end user, is it available? So SYN, that is a synchronize. So the computer says, hey, I want to talk to you. So now it needs a response from the end computer that okay, I'm available. That is the second one. Send ACK, which is acknowledgement. It sends it back to the sender that okay, fine. Let's say computer A sends, hey, computer B, I want to talk to you. Are you available? Then computer B will now send it. I hear you. I'm available to talk to you. Then three now, the bot has acknowledged that okay, they are both available, then this is where the computer will now start conversating. So computer A will now say, okay, I've gotten your feedback, let's discuss. So TCP ensure that there is reliability, there is no loss. So it doesn't want to waste effort, it doesn't want to waste time sending messages that you're not sure if the end user is even receiving it or not. So TCP has this its famous trait is like no, there's no loss. So everything you're sending is going to be received. So and the other data, so it's going to be received as that is the packet sequencing, is going to be received as sent. So let's move on. Introduction to UDP. So UDP, so if TCP is polite now, like let's say TCP is the phone recording. So UDP now is just like the diagram. Now you see that for the broadcasting radio, they are not waiting to hear if you can hear them. They are not saying, oh, the user at the end, confirm if you can hear me, confirm if you can hear me. They are just broadcasting, just like it's just as if it's noise. They're just sending in the rays, sending everything. So UDP, I would say the user datagram protocol. So it's just like a guy. It's like a guy shouting in the market. Now you see the guy does shout. He doesn't care if you're hearing him or not. All he does know that he's saying something. You see some people that is advertising some stuff now. They don't care if you're actually hearing them or if you can even articulate what they are saying. They just know that they are passing information. For those that can hear, they hear. For those that can't hear, well, you find a way to just get yourself. So TCP is connectionless. So there's no handshake. It doesn't go to the end user to say, oh, hey, I want to talk to you, are you available? UDP is it's connectionless. So it doesn't ask if are you ready for us to start a conversation. It just sends immediately. It just starts sending. So now so reliability now is actually broken here. So because it's like a burden to UDP. It's like a burden to show that okay, the end is actually receiving. Just imagine a radio broadcaster now starts asking over the radio that can you guys hear me? Can you guys hear me? It's not even going to be like reasonable. You just be like, what's this guy doing? Just go on with what you're saying. So UDP is fast transmission. Like I said, it's really fast. It doesn't see whether the data, whether it doesn't care whether you're hearing or not. You're just speaking. Imagine it like the person on with a megaphone just shouting. So it's just saying. It doesn't pause to see. Are you guys hearing? You understand what I'm trying to say? It just keep on just saying the word, saying the word, saying the word. There's no delivery guarantee. So it doesn't ensure that what you're sending is being delivered. So we can use the radio broadcasting as an example. The football match you're streaming, you need fast over guarantee that okay, this thing is actually being delivered. So you just want to be at the live spot. You want to be at the live spot. So now for UDP now, okay, UDP there's no ordering, and this is where speed matters. Sorry. So speed matters here, and the the data, whether it's being delivered in its integrity, doesn't matter here. So now for UDP there are two main reasons. A playground. There are two main reasons: for spoofing and for amplified attacks. So now for spoofing, it is fake to fake your identity. It is hard to fake your identity. So you can't really fake your ID in UDP, because it's like fast. It doesn't. There's no two ways communication. There is no like trying to be safe. So it's really hard. So you don't have to complete a handshake like okay, um let's confirm from this person first. Let's know if this person is available. So he can send a packet with a fake return. So and the receiver will just receive it. So it will just accept it, and there's no way to verify if it's really the person that says he sent it that's sending it. Imagine now I claim to be Elon and I send you something, instantly just receive it. So now, and there's no way to reach out to me that, oh, are you really Elon? So this is how spoofing comes in. Then for amplified attacks now, like for in terms of DDoS now. So I can send a tiny UDP request now to a server now to spoof an an IP address. So now a lot of, you just see with, because of the speed now, this is where you see that when people are, and let me say for instance, when you see that some sites will just shut down now because a lot of attacks are just coming, that's with speed. They are not confirming to see if the user end is actually active or available to communicate message with them. They are just being pushed. A lot of requests is just being pushed, and it's anonymous, so it does not require target permission. So unlike the other end, TCP, it requires permission from the other. So you say, hey, are you available for communication? It's now sent back. But UDP doesn't care. I want to speak with you 1,000 words. Are you available for communication? This is like in terms of the TCP now. But UDP will just push 10,000 words at a time. It's at your own pace. If you can handle them, you handle them. So speed is being used here. So in comparing TCP and UDP now, so the TCP is reliable and the UDP is fast, so it deals with fastness. So TCP deals with reliability. So TCP is ordered, TCP is UDP is on order. So for TCP, you send a package named 1 to 5. It has to ensure that that package arrives as 1 to 5. But for UDP, you might get it scattered. 4 might be the beginning one, 5 might be the middle one. So it doesn't just care. So then TCP connection is based. So connection is being based. It has to establish a connection before it starts communicating, before there's any ongoing communication. But UDP, there's none, regardless whether you're available or not. It just starts. So then at the end, which is why TCP now is slower. Reason because it has to check all these things. They have to go a 3 handshake communication first. So then UDP is faster. So TCP, we can, as we say, it guarantee delivery. It ensures that yes, this thing is being delivered. If it is not delivered, it send it back and tell you that, oh, this stuff you sent wasn't delivered. So example, let's say if you're sending an important exam file now, let's say want to send an important exam file now. So when it comes to exam, we know that speed is luxury. Yes, like you want to send how will I say? Back then, like for people that sent, let's say we are receiving an examination file from an organization out of the country. So we need it to be fast. Yes, it's a luxury for it to be fast, but accuracy is necessary. Accuracy is the necessity. Yes. So if imagine now they are sending a question, and when the question comes, you're seeing half question there. You're not seeing it complete. It will make no sense. So this is why TCP is a logic choice to use in important stuff. So now it's guarantees zero corruption. It has no missing pages. Like, okay, yes, yeah, this thing ties down. I can link it down to the CIA track where it has integrity. There is integrity of the document being sent here. There is no missing page there. So it is as it was sent, that is how it is being delivered. So and there's proper sequence. So it's being sent in a proper number. You see number one being sent first, and you see it's being listed 1, 2, 3, 4 or ABCD. So TCP ensure that the way that it was sequenced, the way that it was being arranged, that's the way you see it when you're receiving it. So now if we want to hope on in a live call now, so if we want to hope in a live call, like we want to make a live call now, which one really matters? Okay, like this Discord call you're on in now, what matters here I can say is actually speed. You won't want the fact that as I'm talking, the voice now starts hanging due to high latency, or the network start breaking. Here it's speed that really matters, because you need to be hearing live as I'm speaking. So UDP ensures that, okay, yes, this one is fast enough. This one is faster, and the connections are really are not really how would I put it? The connection doesn't really matter here, but it matters that okay, you're getting this as fast as possible, as fast as possible. So move to the next, being a port. So the port now, what exactly is a port? So remember we said the address, the IP address is like knowing the address of the house. So now the port is like knowing the how would I put knowing the door. If you can see the image I put here now, it's like you see the address. The address is like the building now, but now the port now specify the door. When you get to the house, I just told you that okay, I live in um the house. The flat number is called flat B2. So you get to flat B2, you see about 15 doors there now. You won't exactly know which one it is that I'm actually answering you from. So now the port is like the door. It gives you place, the exact place you're to knock. So now um, in networking now, let's just put it like the port now is the doors into the house. So the port is a 16-bit number. So it ranges from 0 to 65,535. So it's not necessary you know everything. It's not necessary that you say, oh, I know the whole 65,000 ports that's on the network. No. Okay, let's just read our slide now. So it says the ports, it's entails logic communication endpoints. It allows multiple service on one device. So it identifies specific service, yeah, which was just what I just explained now. So um so let's say now in the world of a hacker now, port is really like everything, like everything. So when we run like a tool now, I think when we're doing practical, we'll definitely do it end mapping. So when we run like end map now, we're performing spot scanning. We're trying to see which doors is open. You want to get into a place. You want to get into a room. So you do the end mapping. You want to know which doors. They have points that oh your target is in this house, but where is he exactly? What door? What room number is it? So and you want to know is this door open or is being closed? Can I get into this door? How can I get into this door? So sometimes when we port scan, you see that there is open, some are being closed. So this is like when you see something being open, it's like oh somebody is actually listening. There's an invitation to come in. A thief now when he goes to a place and he sees a door open, that's like wow. There's no need to stress and break in. Just have to walk in. Everybody okay, submit all your items you have. So so the common ports that we have like port 80 for the HTTP, port 443. Remember I said now port is like the door to a house, the door. So if you see now we have remote access, we have in the image we have the web, the file transfer, the collaboration. So but the ports now are the one that tells you the exact door. You said oh you want to go to the social homepage. So there are 4 rooms there now. You don't know there are 4 rooms in one floor. Let's say the remote access room, the web room, the file transfer room, the collaboration room. So it's the port now that tells you, oh, when you get to the web place, you see the public homepage for the social media. You see the social media doorway there. Just walk into there. So these are what like the ports are just for. So the common ports now, like I said, port 80 now is TTP, TTP, HTTP. Sorry. So this is I think this is mainly for the web. Like this is the entry points for web. So we have the ports 443. Also T from 80 to 80/443 are the web entry ports. So then 22 22 is the secure share, that is SSH. So it's like for remote access. This one is really hard to crack too. So the port 21 FTP, the file transfer. So this is for files. Then 25 is for the email. Yeah, that's for the email too. So it's useful for enumeration, finding valid email accounts. Like here. So now the open ports and risks. So now when you run some port scan now, this is when you see that some ports are already open, some are being closed. So if you see the image now, you see a security guard is guarding a door. And if you look behind, you see there's a ladder linked to a window. So while the security man is standing there, because someone can easily follow behind and enter inside the room, get what he wants, and go out. And the security person doesn't even know, he's not aware. He's just there. He's trying to block access from it. But eventually they have gotten access into it already. So this is what like the open ports are like now. So now um let's use a company for example now. If a company has like 15 unnecessarily open ports now, there are a lot of things that could happen. There's more surface attack now. Surface attack is like the total sum of attacks, total sum of ports and service where unauthorized user can attempt to enter or get files from. So now open ports now is like a gateway waiting for connection. So it's like a door waiting for, like it's just look at this, use the window analogy now. You see that it's already open. So it's just waiting for access. Okay, this is for access. So anybody can actually gain access in and out of that place. So when a company has a lot of open ports, there's there's open chances, there's high chances that they are going to be attacks. So you see that each open port now increase the attack because there's going to be service vulnerability. So a port now is only open because a program is listening to it. So if that program has a bug now, a hacker can use it to bypass security. So let's say you see the security standing at the door now. There is, let's say, he's guiding like a tons of amount of money there. Let's say like maybe 1 billion, or okay, let's say $100,000 cash is in there, is guiding for no one to gain access to it. And somebody has already gained access through the window. You see that the person can just easily carry what is guarding and just leave. When the person security goes in and you see that what's really happened, that something has been missing, they have been hacked. So this is vulnerability. So open ports also for information gathering. Now it allows for information gathering. When hackers see that there's a port open, they can through the open port get information. Like a company now, let's say for instance now they have like um where they are storing their data now, and they leave it just carelessly open. Somebody can walk into that place, get data, get information they want about anything, then leave without anybody even saying anything. So and these open ports now, they are like places. Remember I said that they are like the doors, they are like the doors to a particular place now. So imagine that there's a place you're putting where your password is being saved, your data, your credentials are being saved, and that port is being opened. You stand the risk of being stolen, like your credential has been stolen, and that will just gain access to most important files. So the goal of there is one golden rule that says that if you don't need it, turn it off. So if you're not using it, turn it off. This is mostly, you see people, you don't see like the Bluetooth, the Wi-Fi. So can you guys see the screen?
Yes. I,
Number in numeric form. So we'll be seeing 80s. Instead, like I told you, it's not going to be showing HTTP plus or all those language, you understand. So now, and the zero, the O, it shows the process ID. I'm just going to run this now. So we're saying TCP 0.0.0.0.0135. So now this 0.0.0135, this means our local address now, our computer is listening on this port now, this particular one. So all these ones here now, you see listening, they are listening. That means it's being open, it's currently open. So now this is what hackers tend to want to get. So for a port that is being opened, that they can necessary be on. If you're not using the AC, that is just an analogy. Don't leave it on. Switch it off. If you know the port you're not using, switch it off, because as long as it's open, there's chances that it's exposed to risks. So open ports is equal to exposed service. Port scanning identify vulnerability. The next slide now will show how what is being used to scan those stuff. So unnecessarily open ports increases the attack surface. So when you just leave unnecessary ports open, ports that are not being used, they are not even, you don't even need them. This is in the world of networking now. It gives the hackers, they'll be like, whoa, praise God, praise be God. Like, they don't really need to go through many challenges. The windows is just open. Why getting the risk of why taking chances to try to pull a fight with the security man when you can just clamp the window and grab what you want and walk out silently without the security man even knowing? So the hacker will find the port, and if he sees that the service is running, he's going to try to walk into it and find something to do. So this is Wireshark. So what is Wireshark? Now the image here, this is the interface of Wireshark. I believe the last class we were told to download this. Yeah. So I believe we have, if we have downloaded, you see something like this, where we're seeing the file, the edit and stuff, not really necessarily the numbers there that we're seeing. So what exactly is Wireshark? So Wireshark is a packet analyzer, so a protocol analyzer. It captures live traffic. So it's more than that though. So now it lets you see what is really happening inside a network communication. So this is where it gets juicy now. So Wireshark now, it allows you to see not just the you're just seeing that, oh, this is just one dot. It makes you see, actually you can get some password from Wireshark. You can get the credentials from Wireshark. This is what opens it, like it's like the reviewer. So Wireshark now, if you want to understand how attackers intercept data, first of all, you need to see that data. You need to see. So you need to see what is not like you want to attack something, you want to intercept something that you're not seeing. It's not that possible. It's not possible. You need to see actually what is it that you're trying to intercept. So now it captures packet, it shows the destination, and it also shows the source. So it shows where it's coming from, it shows where it's going. So I'm sending a picture from Abuja to Lagos. Wireshark will reveal it that, oh, this picture, it is coming from Abuja, it is going to Lagos. So it won't just see a packet flying in the air and say, oh, you don't know the source, you don't know where it's going. Wireshark reveals it. So, and it shows the protocol. Remember, we have spoken about the protocols: TCP, UDP, HTTP. So Wireshark is like the revealer. So everything we have talked so far, the IP, the packets, the TCP handshake, even the port self, they all happen in the shadow. Those all these ones now, what you can't really see, they happen in the shadows of our hardware, so we can't see them with our naked eyes. I think it's the most popular network protocol analyzer. So most hacker, this is what they use. So in the hands of a hacker, you see the magnifying glass there in the picture. So in the hand of a hacker, it's like a digital microscope that you use to magnify things. So the Wireshark puts our network card into promiscuous mode. So normally now, when a computer listens to traffic, it addresses specifically to it. So the computer says, I want to see everything. Um, how will I say now? The computer now, when a computer now is just like we're looking for how to explain this word now very well. So the traffic now in the computer, you see zeros and one, zero and one. We don't really understand all these things. But now we'll say, okay, we want to understand what's going on. You just see the computer writing the codes of number. But Wireshark now is what now captures it. It brings every raw data out, like brings it out and filters it, stop it at a point. You're seeing it live. I think the next this we're going to do it. So you're going to be running network live as it's going. If someone is, let's say, on a network now, you're analyzing a network, everything going on, if you're seeing it, instead of seeing if it's not if it's not using Windows, instead of seeing just codes or numeric, something that doesn't just give rich words now. You'll be seeing where the users hit John Doe as the username, type 123 or as the password. You see it here, it captures everything. So now this is this visibility now is why the defenders and the attackers study traffic. So you see them, you just see them at front of the numbers, just studying. They are studying because of this visibility. So both the blue team and the red team now. So the Wireshark, what can Wireshark reveal? So Wireshark now, if somebody, let's say in a public Wi-Fi now, or let's say somebody logs into a website now that is without HTTPS now on a public Wi-Fi. So Wireshark now can show us, just like I said, the credential in plain text. In plain text, the username, the password, if it's not being encrypted, you're going to be seeing them in plain text. As the person writes enter send, you see them there. That okay, this is what it came from computer A and it went to the internet. This is where you included it. So you log into your bank details. Let's say chess.com. You open it, log in your username, your password. Wireshark is going to see that, oh, this is where you logged in. It's not just going to say, oh, you type this. This is where you logged in. This is where you are operating. So it's like it shows um the things you're doing on the internet there. So it reveals the source IP, like I've said. It also reveals the destination, where it's coming from, where it's going. It reveals the protocol being used. Are using TCP, UDP, HTTP. It reveals the port number. Remember what to say about the port, like the door. It reveals the okay. You're knocking in a building. You're in a building now. What door are you knocking at? What room are you entering? Wireshark reveals it. The packet size. What size of amounts are you working inside that room with? What's the level of the discussion you have there? It's revealing it. So it's revealing encrypted versus unencrypted traffic. So now, but on the unencrypted traffic, that is where it's just going to they'll be seeing it plainly, like plain text. But the encrypted traffic, or it has to take some extra work to decrypt it. So um if you think that your data now is just private, it's private because it's digital. Let's say people, when people doesn't have vast knowledge about digital stuff, so they'll be like, oh, since it's just digital, everything I put there is like private. So Wireshark is like the reality check. If you can use Wireshark to check all those things, it's like an exposer. It's going to expose the things. Those guys are saying, this thing is really secure. This I'm browsing secure. Wireshark would say what website. You see, people, you enter a website. That's why it's normally you're being advised several times. Don't use public website Wi-Fi for private stuff. You want to log into your bank details, you want to browse on the website, you're logging into a very serious thing, and you're in a public this thing. What if somebody is actually monitoring that network there? Everything you're doing is open. Like, it's just like you showing the person an open book. You're reading out what you're doing. They are saying that, oh, this IP address, it might not necessarily be showing your face, but your computer has an online profile. So like this computer, this is where this computer access. By this time, you walked into, let's say Zenith Bank, logged in. This is the username. This is the password. You transferred to some amount. So all these things are being captured, and now they can impersonate you. They will gain full access to that place you just enter. So in a hacker's perspective now, it's like a man in the middle now. So Wireshark is like the eyes now. So I can sit between you and the router. So it's a man in the middle because it's coming from you going to the router. So I'm in between. I'm seeing that it's coming from you, and I see that it's going to the router. Where is it? The website. You're trying to make payments. You're trying to do whatever. So these are what Wireshark can reveal. It reveals it in plain text. So as long as if you log into an old or a poorly configured website now that still use HTTP, so that's why it's really good to just always check if it's secure. And your let me just tell you the plain truth. If you're using it, your credentials are plain. It's not, you might be seeing it at dot dot dot, but it's being plain. Once we just use this and open it now, it is plain. They can see what you're doing if it's not being encrypted. So now why HTTP matters. So the hypertext transfer protocol now. So it's one of the protocols we spoke about. So we have just seen how Wireshark now can open a packet down to the soul of it. So if an internet stays on HTTP now, so okay, hypertext transfer protocol HTTP, it's not being secured. So, but the advanced one, HTTPS, the S added there is means secured. So anytime you're browsing on the web, you're surfacing on the web, always check this. Have this attitude of always checking. Oh, is this web page secured? Mostly, Steve, I think Google also have this thing that once you're entering an unsecured site, they will warn you. Some people have seen people they'll just they'll be like, ah, these people are just disturbing me. They'll click continue to site. They'll usually warn you that, oh, the site you're entering now, the room you're entering now, it's open, it's not secured. What you're doing there is at your own risk. You can go in there and meet thieves there. You can go in there, thieves can come meet you there and steal your data. You can go in there and come out being robbed. So it is not being secured. So why HTTPS matters now is that one, it encrypts data in transit. So data that is being in transition. So if you see the image now that is being here, you see a letter in an open message. You say, "Hi Alice, my secret is try harder." So it just doesn't make that, oh, once you see that you're HTTPS, you're in a secured environment, that, oh, you're free, nothing can happen there. That doesn't mean. Remember, we spoke on our first class where we agreed that cyber security doesn't mean that there is 100% security. We're just trying to reduce the risks. So our ethical responsibilities now. First of all, let me just say this Wireshark now, it's not an illegal stuff. So that's number one that we have to just make. It's not illegal. So it's a legal stuff. It's only that it can now be used when used out of ethics, it becomes illegal. So let me just say that. So the tools are neutral. That is what it says here now. Tools are neutral. So they can be used both for good and bad. So misuse is what is illegal now. Misusing it becomes illegal. Always operate in an authorized environment. I remember still saying this, that as a cyber security professional, that's what makes you a cyber security professional. It must, even if you see that okay, a company is being broken into and you can actually help. If you're not giving authority, you cannot do anything. Don't say, oh, okay, let's say maybe I'm just practicing. Yes, they catch you and you say, oh, I was just testing my hacking skill. you're going to prison. Let me just state it. Let me state the fact. If you're being caught because you're doing something unethical, so your ethical responsibility is that you must always operate in an authorized environment. Follow all cybersecurity ethics. So you must gain permission, except you're testing your own what belongs to your own network. Now you want to see how Wireshark is happening. It's not whether it's a public this thing. If you're caught, they have the right to fine you, like to take you to court, because you have no right to do that. So this is why you're a cybersecurity expert, you're a cybersecurity professional. So when it is legal now, it's when you're doing it the white hat way, the legal way. So when it's now become illegal, you're doing like the criminal ways. So all this stuff we've been saying today now, you see the wire, the especially using the Wireshark. I believe we have it on our system. You can test all those stuff. So, but make sure if you're testing it on your network. Please, let me say it. You're testing it on your network, not on someone's else, not even your friend, because when things go wrong now, this is where you see, because you can get the authority involved, because this is not just child's play, that you're learning doesn't mean um, that you can make mistakes anywhere you think, because you're learning. You say, okay, let me go to first bank and go and try their network. You want to see what is happening there. My brother, my sister, if you're being caught, you're going to jail. You're going to jail. So the your act is now. So there's a golden rule now governing networking. Don't sniff what you don't own. When using all this stuff, don't go and sniff what you do not own. This is what Lord have done is saying now. So that if it's not your own, whether it's your friend, your best buddy, as long as they do not give you authority to do that, do not do it. So if you stick to your own home computer or your own network, Wireshark is the best way to see the matrix of the internet. So your own, you have your router, you can just turn it on, you check the internet. Next by the next workshop, you're going to your think. I think, but I believe we should look into it. So you see how it's being used. But please do not misuse it. It is illegal. So even if your friend have some people now, I've met with some people that they say why they want to learn hacking, because they want to show their friend have prepared them, they want to use it to pay back. Please, oh, that is illegal. It is really illegal. So authorization is everything. If you don't own it, don't write it, don't touch it. And authorization doesn't mean like, oh, in spoken words. Let me say for instance now, your friend is working at a company and your friend like, you're learning this thing, come and test it in our company now. That's it. They give you authorization. Let it be written, because if something goes back now, they can deny you and say, oh, me, I never said it. What was your proof? So let it be written that, oh, they gave you an authority to test so and so. So, and definitely they'll give you the scope. This is where you're permitted to start, this is where you're permitted to stop. Don't go beyond this place. So this is it. Authorization is everything. And also stay in the lab. Last time we made use of the virtual machines. So that is where it does best, so that nothing goes wrong. Nothing goes wrong. Um okay, so it's our last slide. Uh so if you understand, let me just say this now. So if we understand networking deeply, if you understand networking deeply now, um okay, let me not ask it as a question. So okay, Chisom, you're the first I'm saying here. So